This section introduces actual examples of lava buildings used in Japan. The maximum vertical load supported by the lava building is up to 80 MN. This bridge is the type of 4-span continuous pre-stressed concrete box girder. This lava bearing is classified as the largest in size. This lava bearing has a plane dimension of 2.5 meter, 2.8 meter, and a thickness of 372 mm. The vertical load is 50 MN per buildings. This bridge is a type of 5-span continuous precast concrete box girder. The vertical load is about 11 MN per buildings. This bridge is the type of 5-span continuous pre-stressed concrete box girder. The largest lava bearing used in this bridge has a plane dimension of 1.5 meter, 1.5 meter, and a thickness of 306 mm. Vertical load is the 21.4 MN per buildings. This bridge is the type of 3-span continuous pre-stressed concrete box girder. Largest lava buildings that are used in this bridge. We have used two bearings side by side as one building. The largest lava building has a plane dimension of 1.5 meter and 1.0 meter and the thickness of 240 mm. Vertical load is about 20 MN per building. This bridge is a type of 2-span continuous pre-stressed concrete extra-dose box girder. The largest lava building used in this bridge has a plane dimension of 1.37 meter, 1.37 meter, and a thickness of 285 mm. Vertical load is the 12 MN per building. This bridge is the type of 6-span continuous pre-stressed concrete box girder. This bridge is the first in Japan to use a seismic isolation building that uses high-damping lava as the lava material. The largest lava building used in this bridge has a plane dimension of 0.9 meter, 1.5 meter, and a thickness of 270 mm. Vertical load is 7 MN per building. This bridge is a 1-span of steel arched bridge. The largest lava building used in this bridge has a plane dimension of about 1 meter, and a thickness of 280 mm. Vertical load is about 8 MN per building. This bridge is a type of 7-span continuous cable-stayed hybrid bridge. The largest lava building used in this bridge has a plane dimension of about 0.8 mm, 1.25 mm, and a thickness of 420 mm. Vertical load is about 7 MN per bearing. This bridge is a type of 3-span continuous steel composite truss box bridge. In this bridge, lava buildings are two types used: the bearing for supporting a vertical load and the building for absorbing the horizontal displacement. Building that supports the vertical load has a plane dimension of 2.3 meter in diameter and a thickness of 260 mm. Building that absorbs the horizontal direction of displacement has a plane dimension of 1.4 meter, and a thickness of 470 mm. This building uses 4 buildings side by side as one building. Vertical load is 80 meganewton per building. In this article, we will show the damage example by the earthquake in Japan. Typical earthquake that occurred in Japan is such as the Southern Hyōgo Prefecture earthquake in 1995 and Mid-Niigata Prefecture earthquake in 2004 and the Niigata Prefecture Chuatsu offshore earthquake in 2007. And in 2011, the Pacific coast of Tohoku earthquake and the 2016 Kumamoto earthquake. This is a damaged example of knuckle bearing portion by the Kobe earthquake. This knuckle bearing is a fixed bearing and corresponds to the rotation of gather. The rotation feature was the dysfunction due to the loss of pinport. Due to the downward force caused by the earthquake, the gather's lower flange on the upper part of the building was damaged. The downward force due to the earthquake grew bigger by the rotation moment that occurred in the gather by the horizontal force of the bridge against perpendicular direction. This downward force pushes the lower flange up the tears it down. This is the damaged example of the pot building. Horizontal force is generated by the earthquake. The stopper portion was damaged by the impact with the upper plate. You can see the parts supporting the vertical load deviate greatly. This is due to occurrence of displacement and horizontal force exceeding the design. Same as before, it is the damaged example of pot bearing. This bearing is fixed bearing. The bearing does not move because it is fixed with the side block and the upper plate stopper. However, side bolt was damaged by the tensile force and the horizontal force. In addition, the gather's lower flange was buckled. This is the damaged example of the knuckle roller's bearing. Pin came out the place due to a huge seismic force. The roller fell because the movement of the superstructure exceeded expectations due to the huge seismic force. Same as before, this is the damaged example of knuckle roller spelling. Both were broken by the tensile force and sandwiched between the sole plate and upper plate. Next, same as before, this is the damaged example of knuckle bearing. Gather's lower flange on knuckle bearing was seriously damaged. It was considered that this damage was caused by the local tensile and compressive force due to the inferior bearing rotation. This is the damaged example of substructures with lava bearings. This earthquake is the Chuatsu offshore earthquake. The abutment of the bridge has greatly shifted by the earthquake. As a result, the gather collided with the parapet. The parapet was damaged by the impact. Lava bearings were not damaged, but reduced displacement remained in the lava bearings because the substructure was greatly shifted. Lava bearings are deformed about 150% of the lava thickness. It has greatly exceeded the permissible value of lava bearing. Such a state is very severe situation for the lava bearing. Therefore, the lava bearings were replaced. This shows the repair step of the lava bearing. Step 1. Breaking the pulpit to ensure the workspace. Attach the jack to the lower plate and apply air force to the deformation direction of the lever to release the horizontal force acting on the bolt. Step 2. Jack up the girders to release the vertical load acting on the lever bearing. Remove the bolt that attach the lower plate, and then gradually release the jack. As a result, deformation of lever can be returned to its original state. Step 3. Remove the set bolt and remove the entire lever bearings. Step 4. On the low plate, the new lever bearings attach to a position offset from the center. The deviation from the center value is the residual displacement amount of lever bearings. Because of the girder and abutment is misaligned. Step 5. Fasten the lower plate and base plate, and then fasten the upper plate and the girder with set bolt. By jacking down, the vertical load is loaded on the bearing. After that, it is completed by restoring the pulpit. This is damaged example of the lava bearing. This earthquake is the 2011 Tahoe Pacific Ocean earthquake. This damage is thought to have been caused by a large movement due to the earthquake. Because it was a partial break, it does not have collapsed. This is also a damaged example of the lava bearing. This earthquake is the 2011 Tahoe Pacific Ocean earthquake. Due to the large movement, the lava bearing was damaged. In addition, the stopper of the upper plate was broken. In this article, we will show the damage example by aging. Lava bearings has been covered with a protective coating lava of about 10 mm thickness. Lava bearings, when used for many years, small cracks occur on the surface. This cause is the damage caused by ozone. It will occur the part where lava is stretched. When the crack reaches the steel plate, it will burst the steel plate. Since it takes time to grow the cracks to reach the steel plate, it becomes the observation stage, but you will need repairs before it reaches the steel plate. At present, the use of an improved protective coating lava make it difficult for ozone cracks to occur. This is the example of aging damage caused by collision of steel bearing and steel part. Most of such collisions are caused by the leak of water from the expansion device part. Such collision can be prevented by preventing water leakage of the expansion device. This item is about the maintenance. If you think about the maintenance of the bearing unit, maintenance plan is becoming important. Upon a maintenance plan, you need to plan in consideration of regular inspection, maintenance, repair, replacement. Checkpoint at the time of bearing inspection. This is a line bearing made of steel materials. In line bearing, pinch plates that limit their movement have often shifted. This is due to the occurrence of displacement more than designed of loosening the mounting nut. In addition, it may have cracked with lower shoe. Since the line bearing had been made of without toughness material, it was easy to crack by the concentrated load. This is a pot bearing, just as before, made of steel materials. In this bearing, the stopper for limiting the movement will be broken, or the pinch plate for resisting the upward force will deviate often. This is because the bolt was broken due to the occurrence of displacement more than designed, or the occurrence of upward force more than designed. In addition, it may have cracked with low shoe. Same as a line bearing, since the line bearings had been made of without toughness materials. It was easy to crack by the concentrated load. In recent years, I hear that it has been improved and modified to a toughness material. This is a knuckle roller bearing. In this bearing, falling out of the roller due to the excessive displacement, wear of rollers due to the cyclic displacement, falling off the knuckle by a rotational displacement, breaking of the mounting bolt of the side block, breaking of the set bolt. Due to the high structure height, when the pin roller bearing is damaged, there is a possibility that the step will occur in the load surface. This is the lever bearing. It is a structure that is fixed in the upper plate and the side block. Therefore, we have to consider damage about the stopper, the side block, and the mounting bolt. In addition, there is possibility that the ozone cracks will occur on the lever surface. It is about the inspection along the bearings. Along the bearings, we can be seen the collision of the girder's lower flange, the lag and crack of motor. Inspection along the bearing is very important because it is a plate that connects the girder and the bearing, or the abutment and a bearing. In the regular maintenance work, we clean along the bearing or remove the earth and sand. In this page, it shows the extent of the bearing. Right of the photograph is a knuckle bearing to be replaced. First, jack up the girder and the flaglamp. This is to replace the vertical load of the existing bearing to another flaglamp. Next, remove the bolt, and then removing the existing bearing. Next, remove the existing base plate. Set a new replacement lever bearing, placing on non-shrinkage motor, and jack down. Finally, this construction work is completed. This is the case of replacing the knuckle roller bearing to the lever bearing. This is the case of replacing the knuckle roller bearing to the lever bearing. These two cases are easy to replace due to the high height of existing bearing. This is the case when replacing line bearings to lever bearings. Other case where replacement is difficult. The bearing height was less than 100 mm, so the space was very narrow. If the existing bearing height is low, the construction will be difficult. This is noted in the repair exchange. For example, in the pre-stressed concrete bridge case it will be following, because pre-stress is introduced into girder by a tension cable. It is necessary to minimize the influence by the defect cross-section. At excavation to girder, it must prevent a reinforcement under tension cable from being damaged. Design requirements and quality control standards of lever bearing in Japan is quite strict compared to the international standards. It has been pointed out that the quality of Japan is too high, and it makes the product price higher. Currently, it is processing fixed and movable lever standardization supported by ISO Technical Committee 45 Working Group 14. Depending on the required performance of the bridge, it is being developed or proposed standard that can ensure the completion economy. At the end, because it was limited time, we were able to explain only the part about our design and the maintenance of bridge bearings. And we're very glad that this lecture will help you. Thank you for your attention. This list is a member of Lever Bearing Association in Japan. Please inquire about the bearing. Each company can make technical proposals according to their field of expertise.